Multiplying and dividing fractions is quite different from adding and subtracting them. When you add or subtract fractions, you have to get the same denominator first. You get the same number on the bottom of the fraction. Having done that, you just add and subtract across the top. Multiplying fractions is different. You don't need to find the lowest common denominator at all. To multiply fractions, first, convert any mixed numbers you've got into improper fractions. Otherwise, this algorithm won't work. The fact that you have to do it for multiplying and dividing is the reason I recommend you do it for adding and subtracting as well. Then the first step is always the same. Then, once you've got improper fractions, to multiply them, just multiply across the top and multiply across the bottom. Multiply the numerators and multiply the denominators. And then having done that, just simplify what you've got by cancelling out any common factors on the top and the bottom. Let's try a few. So let's start with some easy examples with no improper fractions. 1/2 times 3/4. If you like, 1/2 of 3/4. Well, there's no improper fractions, so let's just multiply across the numerators and multiply across the denominators. 1 times 3 over 2 times 4. Simplify by cancelling common factors. Are there any common factors? Well, there sort of is. 2 and 4 are both divisible by 2, but they're not one on top and one on the bottom, so I can't cancel out. So I'm just left with 3 out of 8. 1 times 3 is 3, 2 times 4 is 8. If you like, remember how you were taught once long ago to multiply whole numbers? You would have gone, let's say 2 times 4, you'd have gone 2 times 4, and you'd have got 8. Well, now I've got 1/2 times by 3/4. What's common there? How much is common? This, and this are in common, which is 3 out of the 8. And that might be a bit messy. Let me show you another way to work it out. Same diagram at the end. I've got 3/4, so divide a whole into 3/4, and I want 1/2 of that, so divide what I've got into 1/2. That was 3/4, that's 1/2, and I only want 1/2, so I don't want those bits. Again, what have I got? 1, 2, 3 out of 8. So let's try the next one. 2/3 times 4/5. Well, there's no improper fractions, so just multiply across the top, 2 times 4, and multiply across the bottom, 3 times 5. Cancel common factors. Again, 2 and 4 are both divisible by 2, but there's not one on top and one on the bottom, so I can't do anything. 2 times 4 is 8, 3 times 5 is 15. 8/15. Now, carefully, let's try again. 2/3 of 4/5. So here's my 4/5, and I want 4 of those 5ths. And I want 2/3 of this. I only want 2/3. Not that bit, or these. So how much have I got? I've got 8 out of 15. Clear? Let's try some more. 2/3 times 5/8. Well, there's no improper fractions. Multiply across the numerators. and the denominators. Okay, are there any common factors? Yes, there are. 2 and 8 are both divisible by 2, and this time they're on one on the top and one on the bottom. So 2 divided by 2 leaves 1, and 8 divided by 2 leaves 4. Now, do the multiply. 1 times 5, 3 times 4. If you don't spot this here, it's okay. Let me show you what happens. If you didn't spot that, and you just went, 2 times 5 is 10, and 3 times 8 is 24. Well, wait a minute, there's a common factor here of 2. Divide the top by 2, and the bottom by 2. And you get exactly the same answer. So it doesn't matter if you don't spot the common factors here. You can get them once you've got this. But these numbers are bigger. And so sometimes when the numbers get bigger, it's easier to cancel common factors first before you actually do the multiplying. 1/3 times 18. 1/3 of 18. Now you and I both know that 1/3 of 18 is 6. 1/3 times just means to divide this number by 3. But I want to show you the algorithm and how it applies. Well, 18 at the moment doesn't even look like a fraction. If I'm going to use my fraction algorithm, I need it to be a fraction. How can I write 18 as an improper fraction? Because this is just a mixed number. It's just there's no fraction part. Well, in fact, I can write it as 18 divided by 1. The fraction line just means divide, and if I divide 18 by 1, I haven't changed it. So this now is a fraction, and I can use the same algorithm. Multiply across the top, 1 times 18, and across the bottom, 3 times 1. Are there any common factors? Yes, there are. 3 goes into both. 3 goes into 3 once, and 3 goes into 18 6 times. So what I've got is 1 times 6 is 6, and 1 times 1 is 1, which you can just write as 6, not even a fraction. Simple enough? All right, 5 times 2 3/10. Okay, convert all the mixed numbers into fractions, including this one. How can I write 5 as a fraction? Same as before, 5 divided by 1. How do I write this as an improper fraction? 2 3/10. Well, 2 wholes is 2 times 10, 20 tenths, plus another 3 makes 23 tenths. Okay, multiply across the top and the bottom. 5 times 23, 1 times 10. Are there any common fractions? Yes, there certainly are. 5 and 10 are both divisible by 5. Once up here and twice down here. So I'm left with 1 times 23 divided by 1 times 2. Now, because my original question had mixed numbers, if you like, you can write that as a mixed number. You don't have to. An improper fraction is a perfectly good result. But if you want a mixed number, 23 divided by 2. Well, how many times does 2 go into 23? It goes in 11 times, and there's a half left over. Easy enough. If you forget to cancel factors here, that's okay. You'll just have to do a big multiplication. 5 times 23. That's a big number and pretty hard to work out. But if you spot the common factor before you do that, then the numbers are smaller. You will get the same answer in the end. Okay, 5 1/3 times 3/8. All right, turn all the mixed numbers into improper fractions. 5 wholes, 5 times 3 is 15 thirds, plus 1 makes 16 thirds. Multiplied by 3/8. Multiply across the top and the bottom. Look for common factors. Well, 3 goes into 3 once on each side. And these ones are both divisible by 8. Once, twice. So I've got 2 divided by 1, which is just 2.